So the talk is about my experience of doing I/O in the JVM ecosystem. So not only Scala, Java, and my attempt at making that experience better. So when I say I/O, I don't mean any kind of I/O. Like I don't particularly want. For this talk, I don't want to talk about network I/O or DB I/O or those things. This is literally file system operations. So when I talk about file system I/O, file system operations is things like basic things like reading a string from a file, appending some lines, moving a directory here, copying stuff, maybe zip, unzip, changing owners, stuff like that. So all the things that I listed here, you could probably do, if you're familiar with the Unix command line, you could probably do it in your sleep. Like, okay, mv, rm, cat, echo, so on and so forth. But if I were to ask you to do the same things in Scala, well, I doubt many of you would correctly do it in a fair amount of time. And unfortunately, the state of the art right now is this. You'll probably Google it, find something on Stack Overflow, copy paste, and move on, because that's how it is. Unless you already wrote your own library, which does a lot of these things. I mean, this is just an example. I guess the font is not that clear here, but it's some screenshots from Stack Overflow. All I want to say is these are very basic questions about how to read and write a file in Scala. And these screenshots were taken, like, I don't know, a couple of weeks ago when I made these slides. There has this a lot of people are voting them, starting them. And this guy even pointed out, like, hey, this is how I read a file in Scala. In Ruby, Python, and some other language, it's literally one line. Like, you open the file and you read it. What's the best way to do it in Scala? Actually, the top answers in both these questions are not that great. This guy, the top answer here asks you to use a library whose last commit was 4 or 5 years ago. And the top answer here actually leaves a file stream open. Or not the top answer, the accepted answer. So even copying from Stack Overflow might bite you. So let's take a simple example. I want to append some text to a file. And let me write it in the most idiomatic way or the most simple way. So this is what my code would look like. This is some reasonable code. I'm not using any external library for the rest of this talk. I have a file, a java.io.file, has some text. I'm going to need a codec. This is something most of the time you don't care about, but to write a good library, you need to give your users ability to pass in custom char sets or codecs. So and this is stuff like UTF-8, ASCII stuff. In Java, it's the java.io.charset. In Scala, it's scala.io.codec, but they have implicit converters between each other, so you don't have to worry about it most of the time. And this is how you write it. I mean, OK, you had to write, I don't know, 5, 6, 7 lines of code. Not bad. All right. But you can smell like this is not something you want to do it over and over again. You want this to be in a library. And plus, there are some caveats to this. Like doing I/O is hard. That's why very few libraries exist, even now, that correctly does this or covers all cases. Like I just listed some corner cases. Like it's not obvious from this code, like what would happen if the file does not exist? What if you're trying to write to a directory? What if you don't have write permissions? What if it's a symlink? Maybe you want to handle those cases separately. If it's a symlink to a legit file, you may want to follow the symlink, may not. What if there's a write lock? I mean, does the OS do it? Does Java do it? What's going on? And it's not obvious. And there's like a whole ton of things that could go wrong with this code, and you would have to handle exceptions. OK, so in my previous slide, I did not use any java.nio. So that's the new I/O library that Java introduced in Java 7. It was part of the JSR. So let's use Java nio. So wow, that's great. You want to copy a file from a source to a destination. So in Java nio, they said, OK, java.io.file is the legacy thing. Use java.nio.file.path, and there's this files util, which lets you do a lot of things. And you're like, OK, this is great. I don't need any I/O library anymore. This nio is awesome. This will solve all my problems. Until you read the documentation or actually try it. It says, only files can be copied by files.copy. Or a directory can be copied only if the directory is empty. It actually throws java.nio.file.directory not empty exception if your directory is not empty. These kind of things makes you lose trust in the library. It makes you think like every time you use this files util from java.nio, you don't know what else you're missing. I mean, there are caveats to this that's not even covered here. Like, what if this thing did copy directories? What if it was a symlink, and it was a symlink to a directory? Would that work? It's not even obvious from this documentation. Like, what if symlinks to directories should work or not? All right, so let's copy directories correctly using Scala. This is what the code looks like. And I did not obviously try to make the code longer. I went to the docs.oracle examples copy.java and took the Java code, which was 50 lines long, and wrote it in the most idiomatic Scala way possible. And this is how you do it. You're not going to write, like, this is something that you're not going to be able to write it in your sleep. Like, you shouldn't be worrying about I/O every time you want to do some code. You want to copy some files. If you're coming from the shell, is cp-r. Why cp-r is this here? Well, OK. Again, it has other stuff that's not I didn't handle. So let's look at solutions. Obviously, we are not the first people to run into it. People have been using the JVM ecosystem for 20, 25 years. So what exists out there before we go and reinvent the wheel? So there's two very good, widely used libraries in the Java ecosystem, which is Apache Commons and Google Guava. It works great. I have no qualms against them. I used to work in Google, and we used Guava all the time. It's great. But there's some caveats to it. I feel dirty every time I have to depend on a Java library. I don't know about you. Also, the idioms don't translate over. Like, you have to always do this some kind of util dot some things, and you have to util dot do this. Versus if you had to in Scala, I would use probably implicits to decorate my file class to add this. Secondly, the Java type system is not that powerful. I don't know if you're familiar with the scanner class from Java, java.io, which lets you slurp inputs and scan integers and strings, whatnot, from the command line, from any file. And you get this .next int. But in Scala, I would probably write it as .next and pass the integer type class. And I would probably implement like a type class here for things that I can read. So this would probably a:read. And that way, this is extensible. I can use the same scanner to define custom parsers, let's say. And it's not possible here. Like, this is not flexible. And OK, so the next option is, OK, fine, you don't want to use Java library, just use plain Java. And as I said before, like, Java NIO is full of surprises. Like, this is an example that has bitten me in the past. So if you want to count the number of lines in a file, that should be trivial. So again, use that files util. Fine, I don't want to use utils, but what can I do? Is Java. I do .lines.count. This actually does not. It works. There's a nasty bug in it. It leaves a file handler open. It opens a Java stream, and it never closes it. So if you just have a long on this side, you'll forget that this thing opened a stream. If you do it enough times, you would get too many file open exception or something. So again, there are traps everywhere, and this makes you lose confidence in Java and I/O. And this is another one of my favorite examples. This code has no bugs in it, nothing in it. It's just the verbosity. So if you're familiar with the chown command from Unix, all it does, it takes a file, takes an owner, assigns that owner to the file, changes the owner of the file to the string. So if I were to write it in using plain Java and I/O, this is what I have to do. Files.setOwner file, get the file system, get the user principal lookup service, then look up the principal by name and set it. This is no way you could have found this until you know the Java docs by heart or you looked it up on Stack Overflow. All right, OK, enough about Java. Let's look at what can we do in Scala. So there is, in the standard library, there's scala.io.source. It does not solve most of our problems, like zip, chown, finding the number of lines in a file. It doesn't solve any of that. If you just want to like do basic I/O, like read and write, maybe it does. But again, it's not ideal. And from what I've heard from the Scala team, that it's actually targeted for deprecation in the next few versions. There's Scala.io, Scala-io. Again, so this is kind of interesting. So there was a lot of activity on it, and the last commit was 4 years ago. And even the last commit was like a README update, and the last actual commit was in 2011. But OK, it's an old library. The old libraries work. But it has this idiosyncrasy. It tried to do too much. It tried to introduce new concepts, new abstractions for everything that we have in Java, like all the buffered readers and input stream writers and all whatnot. And in the end, it became this bloated thing that was almost as hard to use as Scala.io and didn't do a lot of the developer day-to-day stuff easily. And I bet like the developers would have reached a better point if it was maintained, but it's an unmaintained library. And then there is Ammonite Ops. This is by our favorite Scala developer, Lee Howey. I have no qualms against it. Go use this library. It's awesome. There are some minor things that I don't like about it. It's nothing to do with the library. It's basically, it has a very Unixy, shelly flavor to it. Like if you want to remove a directory, you do this little thing. And that's actually works for the intended purposes, or the original intended purpose of Ammonite, which was for the Ammonite shell or the Ammonite REPL, which gives you a Scala shell and do stuff as if you're in a Unix shell, but it's actually a Scala strongly typed shell, gives you filters and lists all that. And for that, Ammonite Ops is awesome. Like this is the kind of syntax you may like in there. And the other thing that is hard with Ammonite Ops is if you want to do any custom things, like if you want to pass in your own codec, like you don't want to write a UTF-8 file, you want to write something else, you want to pipe an input stream because your other library that you depend on gives you an input stream, or you want to give it a custom link option saying it's a symlink or something, like it becomes hard with Ammonite Ops. And there is this rolling your own. Like if you actually Google for ioutil.scala, you would see tons of results on GitHub of pretty much every library having something called fileutil or ioutil.scala, which does all these things. And I mean, just as there is dry, which is do not repeat yourself, I think there's a more important paradigm we should learn, which is do not repeat other people, including yourself. And there's no reason everyone has to check in an ioutil.scala into their every project. And then there is betterfiles, which is the library I'm going to talk about. It grew out of my frustrations. I now realize it's a pretty bad name for a library, betterfiles. There's a historical reason for it. It grew from me adding implicits to java.io.file and just calling it I put all the implicits in one file, called it betterfiles.scala, and it would add all the things that I need. But it grew to be popular enough now that I regret this name, but OK. All right. So before I go into the design, like the betterfiles library, I want to take a step back and think about what an ideal I/O library should look like in Scala. You know what's great about Scala? It's a melting pot of ideas. Like you have ideas, a lot of different language concepts that come together in Scala. Not necessarily they work with each other in the best ways, but they are all there. And this leads to some interesting situations, like when you want to design some high-level paradigm or a new kind of library, how do you go about it? You can actually see this manifest in this GitHub issue. So this was a Scala slip of someone saying, hey, Scala should have an I/O library. And this went on for pages and pages of discussion where everyone had their own opinion of what's the best way to do about it. So some of the paradigms we can think about when designing an I/O library would be, we can either go a more functional way, like pure I/O. All your side effects are captured using monads, reads through a reader monad, writer monad, no exceptions, no side effects. That's one way. Another is if you're more from the Akka streaming paradigm, you want streaming I/O, you want to think about joining pipes and floats and sinks and sources, and that's how you want to move model I/O through back pressures. And even there's a Scala.js. There's a lot of people who are interested in Scala.js. Like, how do you make it compatible? Like, if you depend on Java and I/O, it's probably not going to work on Scala.js. But OK, even that aside, like, Node.js has this philosophy or this programming model where you pass in callbacks when this is on error, and that's how you are on success, and that's how you handle those things. So you don't do a try-catch. That doesn't. I haven't seen that used in any Scala library yet, but there have been suggestions in this thread to do it that way. And we also have a lot of Java baggage. Like the java.io gives you all those buffered readers and output stream writers and input stream readers. You don't know which one to use. I mean, few of you would know which one to use in which situation, what's best for. Oh, and you'd hear all this like Stack Overflow questions like, oh, I have an input stream. I need an output stream writer. How do I convert those two things from one to another? And so we have to deal with a lot of Java baggage on a day-to-day basis. And you want the library to just work. Like you don't have to think about it. You don't think about when you're using the Scala collections library. You just use map and flat map and filter. So Scala I/O should also be like that. You shouldn't have to think about what do I do or look it up, open your Chrome, Google it. So I went and had my own design goals for this library. I didn't listen to any of the things that were said in the thread. So this is what I want, and if people like it, so use it. If not, go fork this library, start your own. So the first thing I wanted is to be catch-all. Like, I should not have to depend on any other I/O library ever. So I went and made a list of all the I/O utils in Google Guava, Apache Commons I/O. Jod is another excellent Java library, which has a bunch of utilities. And even the Java NIO path and file utils, I just made a giant list of them. I literally printed them, check mark, and moved them to a one state. OK, this is my feature set. Another thing is, like, I didn't want any external dependencies. I just wanted to depend on the Scala standard library, Java standard library. This is another thing. So when I wanted to implement this interface, I did not want to do a lot of things myself. I wanted to delegate everything to Java and I/O, but wrap it around in a safe package so when you actually call copy here, it doesn't throw a directory not empty exception or something. It will work as you expect you think it would work. Also, I didn't want to introduce a lot of new classes. Like, every time I use Java, I don't know buffered readers versus output stream writer versus reader and print writer. There's like 50 of them. I don't know which one to use. That's not the case in betterfiles. You should be able to have just one file class that should do everything, or one path class that should be able to do everything. And we would use implicits to add capabilities to this one file class. It started out historically as implicits added to java.io.file, but then we realized that no one actually wants java.io.file. They wanted like a Scala one. So this is a Scala file class, but there is a low priority implicit you can import, which would convert between the Scala one and the Java one, if you do want to use the Java one. And yeah, I mentioned this before. I didn't want any surprises. Like, if I showed you the API signature and node documentation and asked you, what do you think it would do? You would probably be correct. This is another thing that I've been striving to get at. I haven't quite reached there for version 3. This will be there. So what I mean about this is, like, you should not be able to write a string to a directory. And well, if you try to do it in Java, you get an exception. The question is, this is an open question. I have some designs for it. This is a future work. It's like, how do you do it in Scala so that you can catch it at compile time? And you can. You can have a class hierarchy for different kinds of files, a regular file, a directory, or a symbolic link, and which would have different operations that lets you can't even call .write on a directory. But you sacrifice a little bit of simplicity in the code. You might have to write a match. You may not. So we'll go over that later when I'll show you the examples as how you want to prevent this at compile time. And we want automatic resource management. We don't want to, what happens if you forget to close a file handler or some output stream or input stream? You want things to be closed by default. And there are a couple of clever ways Betterfile achieves that. One by, I didn't want to say the M word, one by using a monad. You get a traversable where I override the for each, so when it's done, it clears itself. I also added implicits to the Java stream classes, so when you finish iterating over the stream, it will auto-close the stream for you. What happens if you don't finish iterating the stream? It will leave the stream open. I'll go over that too. And you want configurability. For example, those are the examples I mentioned. You want custom open options. You want to open the file in a read-only mode or write-only mode, read-write mode, or custom link options. You want to follow a symbolic link or not. You want to be able to use custom codecs, UTF-8, UTF-16. But then you don't want the method signature to be like this long, and you have to fill in like 5 things to write a file. So even though the signature is that long, most of them have sane default arguments. I try to follow the defaults of Java. Like if you did just do files.append, it would have appended in the operating system's default char set. It would not have followed, it would have followed symlink, so on and so forth. But you can override all of those is in the default argument section. Good test coverage, this is obvious. There's a CI build, it goes and creates a test report, and you can see which lines are covered. Documentation, this talk motivated me to improve the documentation, so that's good. Yeah, that's another thing. I didn't want it to be slower than Java. It should be as fast as Java. I have a little star there because I'd go over one case where it's about 8 times faster than Java. But most of the cases, rest of the cases is as fast as Java. And this has been alluded to like probably the 3rd time in this conference. Martin also mentioned it. This is Howie's article about the principle of least power. So here, the least power is Java. So I don't want the core to introduce any brand new concepts or techniques. I just wanted the core to be a simple wrapper around Java and I/O. So the core, this might make most of you unhappy in this room. The core is not reactive, not monadic, not effect-based, not pure. It just calls java.nio, wraps around it, covers corner cases for you. And that doesn't mean that you sacrifice all these things, all these nice things. There are upstream libraries built on top of the core, which does introduce new concepts. So there's a file watcher. So the default file watcher is a blocking thread-based file watcher. But there is a library built on top of betterfiles, which uses Akka. So it's a reactive file watcher. You can attach callbacks, de-attach callbacks, monitor. You get all the Akka goodies. Similarly for Scanner, if you're familiar with Scanner, it slurps inputs. Right now, the only thing you can get is like basic strings and ints. But there's a shapeless scanner. You can say like, I want to read this H list from my input, and you will get back that H list. And again, that's not part of the core library. It's built on top of betterfiles. So as I said, this talk gave me a motivation to improve the documentation. So I'm literally going to spend some few minutes going over the docs on GitHub to give you a tour of the API. Okay. So yeah, this is the GitHub page. And there's a tutorial here. As I said, this is the SBT. You can add it to how you add betterfiles. And these are one example of an upstream integration. If you want to get the Akka-based file monitor, you need to add another dependency. So this one does bring in Akka for you. But by default, this has no external dependencies. So yeah, so let's look at how do you actually create a file. So the most easy way is to just pass in a string to this file constructor. So here you might see that this file is actually the Scala one, the betterfiles one. And I renamed the Java one to JFile. But some people don't like that. You can go the other way. You can rename the Scala one to Scala file and use the java.io.file. But for the rest of this talk or this tutorial, when you see file, it means the Scala one. And if you see JFile, it means the Java one. And there are a bunch of other ways you can instantiate it. You can use a string interpolator. It adds some implicits to the Java one, so you can just do .to Scala and get the Scala one from the Java. And there's some DSLs with like the front slash operator. It's just a binary operator, which you can use to go to particular directories. This one lets you go up, and this tilde is the home directory. So there's all kinds of nice little DSLs in it. So this is the most basic thing when someone's talking about I/O is how do I read and write a file. It's pretty easy. You get a file. You can do all kinds of append line, append, overwrite. This little, if you're a fan of using symbols, you can. I don't recommend it, but you can use write and append, so on and so forth. And there's some write associative symbols too with using the colon. So most of the, actually all the APIs return the file itself. Or let's say if you're copying from source to destination, it returns the destination, all the APIs. So this lets you write very fluent code. So here I'm creating a file, create if not exists, appending a line, appending a bunch of other lines, moving it to my documents, renaming it, changing the extension, and reading the lines back. So I'll go over this later. This lines returns, even though it returns an iterator of strings, it's a self-closing iterator. So if you finish iterating over it, it will close the file for you. Or if you do .to list or .to stream or .to list or .to seek, it will iterate over the files and close the stream for you. But if you iterate halfway through the file and leave it at it and move on, it will not close the file handler for you. And for those cases, there's another way of doing things. We'll go over it later. And yeah, this is the streaming API. So if you just don't want the, in this case, if you just don't want the text, you want a stream, you get an iterator. These are self-closing iterators. And it does have some facilities to get back the scala.io.source classes, so you can do this. And you can, again, write iterators back into the file. This is the byte one, and this is the print lines. This is an example where the thing I was talking about is configurable. So you can just call .write and skip this part. It will write hello world, but it will use whatever the default char set is, which is usually UTF-8. But you can give it a custom codec. You can pass in scala.io.codec, or you can pass in java.io.charset. There's an implicit converter between those two. You can also import this implicit from this is all from the standard library. This is scala.io.codec.string to codec, and you can say, hey, I want to use a custom codec, us-ascii. This might give you runtime exceptions if the codec's not installed, if Java says, I don't know how to parse this codec. But yeah, this is a lot of configuration. And this is not the only default parameters. There's about 5 of them. And I'll go over those in the Scala docs. You can open this file and tell it how to process symlinks and so on and so forth. And this is the part where I mentioned we have to deal with our Java baggage. Like the Java has, this is not even it. There's 50 of these things. Buffered reader, output stream, file system, random access file, file reader, file writer, print writer, writer, reader, blah, blah, blah. And you don't have to ever Google, like, how do I get one of these things given a file? They're all built in. Your IDE should be able to suggest it. It's in the Scala docs. You should, or just go for new and give it this name, and you should be able to get that thing back. And again, most of these things takes in more 3 or 4 arguments. They all have sane default arguments. So most of the time, you don't want to worry about it. But let's say you did want to open a file channel with an offset of 100 bytes. You can pass an offset equal to 100 bytes right here. But by default, it would open at offset 0. And same for this. There's implicit conversions between any of the Java I/O libraries that could be converted to another Java I/O library. When I say implicit conversions, they're not implicitly converted for you. There are methods added to these classes which lets you convert them. So given, let's say you did get an input stream, and you want to convert it into a buffered input stream, so this .buffered is added to the Java input stream class. So you can do all kinds of conversions. Again, all of these have method parameters that I didn't document, that I didn't display here, but they all take in all kinds of configuration, and they all have defaults. So this code, all of these compiles. I'm using tut to compile my documentation. So this is the thing that I was alluding to about compile time safety of operations. So you can use pattern matching to get a nice syntax. For example, I want to check if a file is empty. So I want to do this. So if it's a symlink, check if the destination of the symlink is empty. If it's a directory, check if the directory is empty, which is I don't have any children. If it's a file, check if it has 0 bytes file. So you can use this pattern matcher. So file.type.symlink, it gives you, it unapplies to the destination. The directory unapplies to the list of children, or direct children, not it's recursive children. And this is just a regular file. It pattern matches to an iterator of byte. And you can do whatever you want. And these are not the only 3 kinds of files that are possible, believe it or not. You can have Unix processes, pipes, so on. Those are modeled as files in the Unix system. So, but they're not exposed. You just have to handle them one by one. So, and of course, if you're familiar with the Scala, you probably know this, that you can also use extractors on the right-hand side, on the left-hand side. So here I have some file on the right, some directory on the right-hand side. I'm using pattern matching to get all the children under this directory. So that's a nice trick you can use. Again, it has all these utils for if you're familiar with Python or Shell, you can do this syntax of globbing. This finds all the Java and Scala files. You can use some other syntax. You can pass in some regex syntax to do this, to glob. And these are, again, strongly typed. You can't pass in some weird, some random syntax that's unsupported. All right, so these are the file system operations I was talking about. So these are things like touch, which updates the last update time, delete, clear, rename, move, copy. You can create a new symbolic link. These are all the checksum. You can compute MD5, SHA-1, SHA-512, set owner, set group. You can use the write associative operators to, this is kind of inspired by the cat. I don't recommend using operators unless it's this one. This one's, I think, is reasonable. Sorry, not this particular one, but for using the / for going into children. And it has some nice little temporary file and temporary directory utils. So all of these, as I mentioned before, are fluent. They return the file itself, unless it's this one. So it has moved to destination. It returns the destination instead of the source. So you can chain these things if you want. It looks pretty nice. So this is kind of inspired by the Ammonite ops library. So if you want to make your code look like Unix, you can import this commands package. It just gives you a nice way of calling file.touch, but you can just make it look like some Unix commands you're familiar with. There's way more of these. There's about 50 of these. I didn't get time to document all of them here in the README, but you can read the Scala doc. So this is the attributes API. So things like name, extension. So if you actually try to get name in Java, you think it's going to be simple. It's just files.name, but it actually does some weird stuff. Like it returns null if it's a root file, the root directory. And extension, it returns null if it doesn't have any extension or something like that. So these are all type safe. So name returns empty string, and there's also name option, which should return none for roots and some string for every other file. Same for extension, it returns an option string. And again, you can pass in a bunch of parameters to extension. It has like 6 parameters extension. So why would you need 6 parameters to do extension? So if you have a file like .scala.html, do you want .html or do you want the whole part? How many parts do you want? Do you want the dot or do you not want the dot? Those are all configurable, but the default arguments are not shown here. You can read it in Scala doc. Same for this, last modified time. This returns Java 3.10 Java instant, so on and so forth. The size is interesting. It actually works for directories. If you calculate, you call file.size on a directory, you would just get back the size of the IO node, which is like 4 bytes or something in Java. But this actually gives you an option. Do you want the IO node size? It's going to be as big as 4 kilobytes all the time. Or do you want the recursive size of the directory? Or till how much depth do you want? Is empty is the example I showed about. You can get all the POSIX or the DOS attributes. And there's some nice little tree operations you can do. You can check if it's a parent of something, sibling of something, get siblings, I don't know, grandchildren or grand siblings or something. And that's another example of, so this link option is, let me see if I can go there. Oh, well. So this link option is not something I invented. This is from java.nio.link option, and you can give, when you do is directory, and you're asking a symlink if it's a directory or not. Do you actually mean that symlink is a directory or the target of the symlink is a directory? So you can pass in the link option. And this is also, so this is if you want to pass in the exact Java instance, or you can pass in the Scala one, which is slightly more code style-wise better. Like it doesn't do this all caps thing and underscore, so, but they're the same things. This is again an example of chmod. You can do add permission, remove permission. This POSIX file permission, again, I didn't invent it. This is from java.nio. And it also has betterfiles equivalent, so which follows Scala code style. So again, camel case, no uppercase, things like that. But you can also pass in the Java one. So file comparison, I would not recommend you to use double equals. What does it mean? File equal to file 2. It actually is what it does is checks if the two files have the same path. And the triple equals checks if the files have the same content. It works for directories also. It would recursively check the directory structure. But again, like someone else reading the code doesn't know what double equal and triple equal means, so I would recommend use same content as, same path as, and same for the nots. But I know some of you love symbols, so there's symbols for you. And so when you're listing files, you have the option to pass in custom ordering. I know you can do it in Scala. You can do sort by, but these are things that are available down at the operating system level also. So there are some default orders built in. You can write your own. So you can order by name, by size, by modification time. You want the first one, the most recently updated one before or after, or by directories first, or by directories last. So there's a couple of orderings you can pass in also when you are listing. And zip, you don't have to depend on any zip APIs. This works. So it's trivial. If you have a zip file, you can just say unzip to. And you don't even have to pass in the destination. By default, it unzips to a temporary directory and returns you that directory. I might have used it somewhere. Yeah, this is the one. So you don't even have to pass in destination. Same for zip. You don't have to say, what's my destination? You can, here I do. I said, OK, put it in my desktop. But again, it returns a temporary zip file, so you can do all that things. It also has support for gunzip. This is an example. You can, how simple it is to parse it. This thing will be like 100 lines of code in Java. This is the part where betterfiles does resource management for you. So it doesn't leave file handlers and streams open, or tries not to. So all the things, so this is a little bit of dark magic, because it looks at the structural type and sees if there is a closed unit on the Java class. Then it adds implicit to it called .autoclosed, which returns traversable. You don't need to know the implementation details, but pretty much anything that has a .close in Java, you can call .autoclosed, and you get back a traversable, at the end of which, at the end of the for each, it closes the stream for you. So you can write this in this syntax. Same for like all the things. This is another example. And if you don't always want to write .new Java class .autoclosed, there's a shortcut for it. You can just skip the new, skip the autoclosed, and just write buffered reader or input stream. It would return this managed resource. This is basically a monad on buffered reader, and you can map and flat map over it. So yeah, this thing is safe. This will close the stream for you once the reader is done, once this thing executes. And the only caveat is, again, this has to traverse. Like, let's say for some, like halfway through, this foo throws an exception, you would leave a file handler open. This is an example of how to write you can write your own auto-closing iterators or auto-closing streams, and this is an example. Scanner. So many of you have used the Java scanner. I talked about it briefly before, but this is a more Scala-friendly one. So you have some hello world 1 through 2, 3. You can create a new scanner, again, using that thing, new, pass in, and the thing. Then you don't have to do next string. You put a next type class, and you can pass in tuples. There's a library built on top. You can pass it a hlist, a shapeless hlist. And this thing is actually, if we click on the benchmarks here, I can't open new tabs for some reason. It's actually 8 times faster than the Java scanner. The reason being the Java scanner uses regexes to find the next integer or next strings. This one uses vanilla parser combinator string tokenizers, and it turns out to be way faster than regexes. And this is an example where it shows the superiority of Scala using Scala type classes, because you can write your, let's say you have your own class animal, and it has 2 kinds of animals, dogs and cats, and you want to parse an animal. So you just have to implement this scannable type class saying, okay, given a scanner, how do I get back an animal? Okay, if this is some stupid example. It says if it's Garfield, it's a cat, else it's a dog. But now, once this implicit evidence is there that, okay, given a scanner, I can get an animal, you can just do scanner.next and pass an animal. This is something that's not possible in Java. File monitoring. So I don't know how many of you use file monitoring. Is basically like if some changes happen to a file system, you want to get back a callback. There's a whole another talk I can do on this. It's like how the Java one is terrible, has so many bugs. I actually documented them. If you actually go to the monitoring, there's a README on it. It tells you all the other caveats and bugs with the Java one. So this solves, and the interface is terrible for the Java one. So the one in betterfiles, all you have to do is you pass in what file you want to watch. You can say, do you want to watch, if it's a directory, watch it recursively or not. Or you can pass in a max depth also. You can, by default, it's int or max value. And then you get to override these 3 things. And that's it. And there's actually a 4th one on exception. If an exception does happen while watching a file, the OS doesn't let you even watch that. So there are 4 things you override, and that's it. And you can start at any time, stop at any time. And this is one if you want to create custom events. Like these are the 3 events that's possible in most operating systems, but some reason you want to do more stuff, you can do it this way too. So this is the example. So the previous one was, it was called a thread-backed file monitor. So this is a very simple abstraction. It uses java.util.threads underneath. But this is an example where we build a much more powerful paradigm on top of it. So this is a separate library. You have to depend on betterfiles-aka. So this lets you design file monitors, but using aka actors. So you get a message saying there's something happened, and you can react to it. And you can, it has this nice DSL. You can attach on the event type. You can attach a function saying this is the callback, or you can attach multiple ones. So for if there's a create or a modify happened on this directory, and then do something. All right, that's my tour of betterfiles. Go back to the presentation. I'm not going to go over this, but Martin already talked about things like the future of the Scala ecosystem, like something like this belonging in the Scala library, the Scala default library or not. As many of you probably realize that the Scala library is very slow moving because for all backwards compatibility reasons, there's like 1 release a month or 1 release a year. And something like this probably belongs in the standard library once we do a split where we have the core, which is just the minimum needed to get the Scala C working, and anything else goes like in this universe where you have net, JSON, and IO maybe belongs there. So I'm not going to go over this. So that's it for the talk. So the source is here. There's an active Gitter channel. There are no open bugs yet, or no open bugs that are right now. There were bugs before that are closed. There are some 20 feature requests. The library is it's 440 lines of code. That's what it is. That's it. It's a very small library. In fact, there are more people who start the project on GitHub than there are lines of code. But it has about 3,000 lines of code which for tests and benchmarks. It's being used by my company and some other places. There's a lot of Maven downloads I'm seeing. But yeah, use it, report bugs, pull requests. That's it. Okay. Do you have any questions? Hey, Eugene. Oh, do you have the microphone? Just yell. I'll repeat your question. Mm-hmm. Mac? Ah, okay. So the question was for file monitoring, how does it operate across operating systems like Windows versus Linux versus Mac? I don't. I use the Java file watcher. In java.nio, there's a file watcher. And it's pretty terrible. It has all kinds of bugs. Like if you create a new directory, inside a directory you're watching, it will not auto-watch it. Or it can only watch directories. It can never watch a file. So you have to do a trick to watch the parent of a file and just look for the changes in that file. So it handles all those tricks for you. But I don't do any operating system level checks because that's handled by Java. Yeah. Yeah. Mm-hmm.
Does this library provide some sort of like Scala Libraries or Arc support? So you can say, give me everything, or I just want this.
Right.
Conversion, but not the other.
Right. So that's a good question. So the question is about there are things that are not recommended, which is mostly the symbolic stuff, like do you want to use the symbol or not? Right now, there is no differentiation. There are a couple of ways to solve it. One is put all the things that I don't like, the symbols, in a separate import if you want symbolics. I think it kind of goes with that Unix-C DSL if you want it or not. The other way is to add some annotation or something, but that's something I haven't done yet, but I'll be doing it soon. Right. Right. Yeah. 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 The which class? Yeah. So you have there are two ways. You can write an option saying like I was able to scan or not. So there are two flavors to it. I didn't go really deep into it. So there's a one exception-y one, throw an exception, and there's like an option one which says I could scan or not. So there are two flavors of it.
Quick question. Are you using Scala-ARM for resource management?
Scala what?
Scala-ARM, the library?
No, it does not depend on any external library at all. Yeah. But there are things that I learned from Scala ARM to use the ARM in here.
Cool.
All right, that's it. All right, thank you guys.